You hear the word Linux thrown around all the time, right? You'll hear tech pros talking about Kali Linux, or Ubuntu, or Parrot OS, but they all trace back to that one name, Linux. And that brings up a question I see all the time. What is Linux really? Is it the whole system you use on your computer, or is it just one piece of the puzzle? Well, here's the fun part. It's kind of both, and once you get that distinction, everything else just clicks into place. So let's break it down. To really get what Linux is, we have to start at the very foundation, the absolute heart of the machine. We're talking about the kernel. The easiest way to think about it, it's the engine of your computer. So what does this engine actually do? Well, the kernel is basically the ultimate translator. It's this core program that sits between the software you use, like your web browser, and the actual physical hardware. Your CPU, your RAM. It takes what the software wants and turns it into a language the hardware can understand and act on. The whole story starts back in 1991 with a programmer named Linus Torvalds. He created the Linux kernel because he wanted a direct line, a way to talk to the computer's hardware without any extra stuff getting in the way. You can almost picture his first creation as just this super simple but incredibly powerful window for giving commands straight to the machine. So let's make this real. How does it work moment to moment? Okay, imagine you click Save on a document. That simple click creates what's called a process. The kernel immediately jumps in to manage the resources for that process. It knows you need to use the hard drive. It then translates your save command into instructions for the drive, and boom, the hardware writes the file. The kernel is that essential middleman for every single thing your computer does. All right, so the kernel is the engine. That's a great start, but an engine by itself isn't a car, right? So how do we build a full system that we can actually drive? Well, that's where the operating system comes in. A Linux-based operating system is built on a pretty simple formula. You take the Linux kernel, there's our engine, and then you start adding layers on top of it. You add software applications, and you add a graphical user interface, a GUI, so you can click on things. That whole package all together is what we call a Linux operating system, or maybe more accurately, a Linux distribution. Now, you might be wondering why there are so many different Linux distributions. The secret sauce, the reason for all this variety, is this hugely important idea called open source. It just means that the original code, the blueprint for the software, isn't locked away in a vault somewhere. It's out there in the open for anyone to see, to use, and, this is the crucial part, to modify. And this really gets at a completely different way of thinking about how software is made. With closed-source software, one company holds all the keys. They decide what gets updated, and progress can be pretty slow. But with open source, the code is public. The community of users itself gets to drive the updates based on what they actually need, which leads to this incredibly fast collaborative innovation. And that's the real magic of the open source model. I mean, think about it. When you have thousands of brilliant, creative people all working on the same project, it gets improved and polished at a speed that a single, closed team could never hope to match. The software literally evolves to fit the needs of the people using it. And this is why we have this amazing world of Linux flavors. The cybersecurity community, for example, took that base Linux kernel and built things like Kali and Parrot, packing them with tools for hacking and security. Other groups built really user-friendly versions like Ubuntu and Fedora for everyday use. Every single one is tailored for a specific purpose, and it's all possible because it's open source. Okay, so we've got our kernel engine and the OS body of the car, but how do we, as the driver, get precise, direct control? For that, we turn to one of the most famous and most powerful tools in the Linux world, the terminal. The terminal is your direct line to the engine. It's a command line interface. So instead of clicking on icons and menus, you're typing out text commands. And these commands, they bypass all that graphical stuff and speak directly to the kernel, giving you a level of control that's just completely unmatched. And the language you speak in the terminal has evolved too. It all started with the original shell called sh. Then that was improved into bash, which is still super popular today. And now we have modern shells like zsh and fish that add all these cool features like auto-suggestions, making the command line even more powerful and way easier to use. Okay, so let's put it all together. We have this powerful kernel, a super flexible open source operating system, and this direct control terminal. So what is it about that specific combination that makes Linux the absolute go-to for hackers and cybersecurity pros? Well, it really boils down to a few huge advantages. First, you get total control. I mean, you can manage every tiny detail of the system, right down to the most specific user permissions. Second, the toolkit is just incredible. Distros like Kali come preloaded with an entire arsenal of security tools. Third is automation. The command line makes it ridiculously easy to write little scripts to automate complex jobs. And finally, you get total transparency. You can actually see exactly how your OS is talking to the hardware. And that, right there, is the real bottom line. With most operating systems, you're limited by whatever buttons and menus the developers decided to give you. Linux just doesn't have that limit. It hands you the raw engine and a toolbox, and it gives you the power to build your own custom operations, things that go way beyond what any standard graphical interface would ever let you do. So you see, Linux isn't just a kernel or an OS. It's really a philosophy of control, of transparency, and of community-driven power. Now you understand the whole architecture, from that core kernel all the way to the terminal.